The most powerful engine stems from General Electric. It is a dual-rotor axial flow turbofan, and it will be solely sourced to the Boeing 777X, with the biggest variant producing over 110,000 pounds of force. But there are many different types of engines being designed right now, and some of these are pretty unconventional, while others are just simply amazing. So without further ado, let's look at some of the best aerospace engines. We begin with number 7, and it's a fluidic propulsion system. This new type of design kind of looks like a Dyson fan, and it utilizes high pressure laminar airflow. It is a unique system which combines a gas turbine, compressor, and fluidic thrust augmentation that is distributed across the airframe. It potentially can lower fuel consumption by more than 50% and reduce weight by 30% when compared to a conventional turboprop. So this is a really good idea for airplanes and electric VTOLs. Now the setup has been tested already in the scale J2000, but some of the larger thrusters will reach over 5,000 pounds of force and propel crafts to over 400 miles per hour, which would be pretty amazing. At number 6, the electric plasma engine. Wuhan University has come up with a very intriguing engine, which does not require fossil fuels. It instead utilizes microwaves to energize compressed air into a plasma state, and then it expels it like a jet. Now, these thrusters can produce 28 newtons per kilowatt, so it is considerably better than an ion thruster, but we have to keep in mind that this only works in the air. But you still need a high energy source, likely in the kilowatt range, and this gives it a below average thrust to weight ratio. It also needs compressed air, and it outputs at high temperatures, so whether or not this thing is really practical in aerospace applications, well, that is another question. At number 5, the Monarch 5. UAV Turbines recently revealed this turboshaft engine, which can run on pretty much everything, including natural gas, hydrogen, and even Jet A fuel. This is an invaluable system for hybrid electric aircraft because it can power the propulsion motor and use the excess energy to recharge the battery system. The engine was recently tested on a UAV, and this will lead to longer flight times, possibly 3 times greater than solely powered battery flight. Now, obviously battery technology is going to improve, but it's still 40 times less the energy density of jet fuel. So these types of turboshaft engines will increase the viability of hybrid aircraft. The next position is a very intriguing development, and it's called the Tempest engine. Now, the next generation of fighter jets will have high power demands due to laser weapons and electromagnetic technology. So most old engines out there are not really up to the task, and they don't have these kind of power outputs. Rolls-Royce has a new answer to this problem, and they are working on embedding their starter generator into the core of the engine. This will save space and eliminate the need of a gearbox, thus making a lighter and more stealthy aircraft. This new engine will be incorporated into the Tempest fighter jet under the British and Italian Air Force. But the final power output numbers are still not known just yet, but it's highly probable that this is going to produce more power than any other jet engine out there. That's number 3, the Fenris air-breathing engine. Now, there are plenty of new rocket engines coming out there, and some of them are pretty intriguing. This particular one is air-breathing, so it does not require a separate oxidizer and tank, so it's considerably lighter. The key to this particular design is its Tesla valve, which maintains a high degree of airflow without moving parts. Even though they did build a prototype, I'm a little bit skeptical about this idea because the Sabre engine had to undertake massive ingenuity and engineering just to pre-cool the air going into the engine. But if proven, it would make rockets drastically lighter and cheaper, and that's always a good thing. Now we get into the weird stuff and look at number 2, which is a pulse detonation engine. And these weird propulsion systems use detonation waves to combust the fuel and oxidizer mixture. They operate by injecting propellants into long cylinders that are open-ended on one end. And when the gas fills the chamber, the igniter is triggered. This creates a shock wave, which pushes out the gas before it has time to expand. The engine operates on pulses, so a controller dials in the frequency of the detonation and determines output thrust. So they're quite a bit lighter because they don't need a compressor and they can handle high speeds, up to Mach 5. But the detonation is hard to perfect and they are very loud engines. The first flight of a pulse detonation engine took place on a modified Rutan, and it threw out roughly 200 decibel detonation waves, which caused structural problems. So tests were very limited to say the least. However, the Russia Space Agency has developed an oxygen kerosene variant, and it's officially dubbed as the world's first pulse detonation rocket engine demonstrator. I'm not exactly sure if it's a reliable prototype, but nevertheless, it's a very exciting development, and it's going to be interesting to see if they actually put this on a rocket in the future. Now we get to number 1, and it's the rotating detonation engine. This is very similar to the pulse detonation engine, but a rotating variant is superior because the detonation waves cycle around the chamber instead of being purged. Now once again, research has been very limited on this type of engine, and it's very tricky to get the fuel burn just right. I think in the future that this design is going to be perfected by a machine learning algorithm in a virtual environment. Nevertheless, a small team affiliated with the US Air Force has already built a small engine. It runs on a hydrogen-oxygen fuel mix, and it produces around 200 pounds of force. This was a big game changer though, and it could eventually be used for the upper stages of rockets, because it is very lightweight. However, they are still very loud, and they are not a universal fit for all types of aeronautical applications. So what do you think of all these engines? Please let me know in the comments, please like the video if you enjoyed it, and also make sure to subscribe to my channel.